So continuing with part 2 of 5.1 notes, we have a few more examples before we are done. So if we're given an inscribed square with side equaling 10, what is the exact circumference of circle W? So we have to start thinking about the properties of our squares, how they fit, how they relate to the pieces of our circles that we know. One of the things that's not drawn on here, but we're going to need if we're going to do circumference, is we're going to need a diameter. And the minute I draw that diameter in, I see that there is a special triangle. And yes, it always comes down to triangles. And since this is a square, that means there's a right angle. That means that inside red, right here, is a right triangle that I can find the length of that diameter with the Pythagorean theorem. And so I know the diameter squared is equal to 100 plus 100. You know, the diameter squared is equal to 200. Undo squaring with square root. The diameter is 14.1. Take the diameter to the circumference formula. And our exact circumference, 14.1 pi, which is approximately 44.5 units. When we get to handling radicals exactly, I'll show you how to do an even better exact answer for circumference. Now, if I'm given a circle with circumference equaling 65.4 units, find the diameter. Again, take the formula, substitute in the value that you were given. So 65.4 is equal to pi times d. Divide both sides by pi. Here you're going to need to use your calculator. Diameter is going to be 20.8 units. Once I know the diameter, finding the radius is just taking half of that, and that means that the radius is 10.4 units. And we're not going to worry about exact circumference today. Now this next one also is going to be dealing with properties of triangles, of inscribed figures inside of our circles. Given this diagram, find the radius. Well, this line right here is the diameter. It also happens to be the hypotenuse of that inscribed right triangle. So d squared is equal to 10 squared plus 12 squared. D squared is equal to 100 plus 144. D squared is equal to 244. D is approximately 15.6. The radius is going to be half of that, which is 7.8. And the exact circumference here, we'll use our decimal, 15.6 pi units. Again, when we get talking about how to handle square roots exactly, those answers will be better. Given a square, GHJI, with an inscribed circle M, find the diameter and find the radius. At first, it doesn't seem like we have enough information, but remember this is a square, so this side is also 18. Finding the diameter, if I draw one in here, I see that the diameter is really the same as the sides. If you think about putting a square in a box, the diameter is the same length as the side of the square. So that means the diameter is 18 and the radius is 9. So it looks like a very complicated problem. When you just draw it in, you quickly see the diameter is the length of the circle if it's inscribed in a square. So finding the exact circumference is as simple. Circumference is pi d. The circumference is 18 pi units. And our last example for this lesson is dealing with an inscribed quadrilateral. Find x and y. And if we remember, we have a theorem that says With inscribed quadrilaterals, opposite angles are supplementary. So I can set up two equations. I can say that 14x plus 8x plus 4 equals 180. 22x plus 4 equals 180. Subtract 4 from both sides. 22x equals 176, and x is 8. The other equation, so I just did those two. The other equation I set up is that 90 plus y is 180, and so y is 90. That is your introductory lesson to circles. Good luck on your